Assalamualaikum warahmatullahi wabarakatuh. We are student of BTU 1212 Chemistry Section 1 under guidance of both Dr. Khairil Anwar bin Abdul Hamid and Dr. Muhammad Shahrul Azwar. We are from Group 4 and we are going to present Lab 6 reaction rate. Group 4 consists of 4 group members. The first one is Fakrul Razi bin Junaidi. Second one is Wan Am Syafiqri bin Muhammad Hassan. The third one is me, Wan Muhammad Afif Hilmi bin Muhammad Noor. And the last one is Muhammad Azizi bin Jamal. My name is Wan Muhammad Afif Hilmi and I'm going to explain some of a bit of Lab 6 reaction rate and mostly about the abstract of this experiment. The aim of this experiment are to determine the effect on how the nature of reactant, the concentration of reactant, the temperature, and the presence of catalyst effect, the rate of reactions. Reactions occur when reactant molecules collide with proper orientation and with energy equal to or greater than the activation energy. We have two methods for this experiment, which is determining the effect of concentration on the rate of reaction in part A and determining the effect of temperature and catalyst on the rate of reaction in part B. Part A involves placing 50 ml of 0.1 sodium thiosulfate in a canonical flask and then placing the canonical flask on a piece of white paper with a cross painted on it. The timer was then started after 10 ml of 0.1 HCl was added to the canonical flask with a glass rod. The mixture was continuously swirled until the cross on the paper was no longer visible. The time it took for the cross to vanish was then recorded. With distilled water added to the sodium thiosulfate, and lastly, the step 1 to step 3 were repeated. For part B involves placing 10 ml of 0.25 m oxalic acid solution into two test tubes labeled A1 and A2. 5 ml of 0.02 km NO4 solution and 10 ml of 2M H2SO4 solutions were added to test tube B1. A glass rod was used to stir the mixture. Test tube B2 was filled with 5 ml of 0.02 kmn O4 solutions and the 10 ml of 2 MHSSO4 solution as in test tube B1, followed by 5 drop of 10% MnSO4 solutions. Boiling tube A1, B1, A2, B2 were immersed in hot water at 3 different temperatures, which is 300, 400 and 50 and 500 degrees Celsius. The solution in test tube A1 and B1 was mixed. The amount of time it took for mixture to become colorless was recorded, while solution A and B, A2 and B2 in test tube and test tube A2, B2 were mixed. Finally, time how long it takes for the mixture to become colorless. Step 1 to 5 were repeated with the order. We can see that for part A, the test tube with the highest concentration of Na2S2O3 will have the shortest time for the cross to disappear. This is due to the fact that higher concentration cause the rate of reactions to increase. For part B will then have the highest temperature and the additions of catalyst. which will lower the activation energy and increase the kinetic energy of the molecule, causing reaction rate to increase. As a result, the time for the cross to vanish will be short. That's all for me. I will pass it to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fakrul Rasidi Junaidi and my matrix number is TJ21054. Okay, now I want to present about methodology. The content in methodology is reaction rate is calculated using the formula rate equal delta bracket C over delta T, where delta bracket C is the change in product concentration during time period delta T. The rate of reaction can be observed by watching the disappearance of a reactant or the appearance of a product over time. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Amshah Fikri, matrix number TH20029. Now, I'm going to present the result and the discussion of this experiment. For part A, this is the result that we obtained during doing the experiment. We obtain the concentration of sodium thiosulfate when it is diluted with distilled water, and we also obtain the data, the time for the crust to disappear when the diluted sodium thiosulfate is added with hydrochloric acid. Next, we also obtain the rate of reaction of this part of experiment. So the result is as in the table. Next, for the result of the part B of this experiment, so for this part of experiment, we take two solutions, which is potassium permanganate and oxalic acid, mix it in a beaker and record the time taken for it to become colorless. So the data shows the time taken for the solution to become colorless with and without the catalyst, which is the manganese sulfate at 30, 40, and 50 degrees Celsius. After obtaining the data, we calculated the rate of reaction of this part of the experiment for, for 30, 40, and 50 degrees Celsius with and without catalyst. Next, the calculation for part A. So the first calculation that contained in this part A is the concentration of the sodium thiosulfate after dilution with distilled water. So the formula that we use to obtain the concentration of sodium thiosulfate after dilution is the formula M1V1 equals to M2V2. So here's an example. Next, to calculate the rate of reaction of this experiment, we take 1 divided by time for crust to disappear at its concentration. Then we get the rate of reaction. For calculation of part B, that is only to calculate the rate of reaction. So the formula is 1 over T. T is the time taken for solution to become colorless with or without catalyst. For graph of part A, we take concentration of sodium thiosulfate after dilution as y-axis and the rate of reaction as x-axis. So we can see that as the concentration of sodium thiosulfate increase, the rate of reaction also increase. For the graph of part B, is so the rate of reaction is at y-axis and the temperature is at x-axis, and we can see that as the temperature increase, the rate of reaction increase. But in this graph, there is the series 1, the blue line, and the orange line is series 2. So for series 2 is the is for the series blue is without catalyst, the manganese sulfate, while the series 2, the orange line is with the catalyst. So we can see that with the presence of catalyst, the rate of reaction is significantly higher. We move on to discussion. So for part A, for this part of experiment, we can see that as the concentration of sodium thiosulfate increase the time taken for the crust to disappear decrease. Concentration of sodium, so this means that when the concentration of sodium thiosulfate increase, the rate of reaction increase. So the rate of reaction is the speed at which chemical reaction takes place. So for this experiment, we want to see how this concentration affects the rate of reaction. So when the concentration of sodium thiosulfate is high, there is more particle of sodium thiosulfate moving together that causes more collision to happen between sodium thiosulfate and hydrochloric acid that leads to the rate of reaction to increase. For the discussion of part B, so for this part of experiment, as the temperature increase, the rate of reaction increase. When temperature is high, the particle gain more energy that leads to increase of collision between particles, thus increasing the rate of reaction. So for this part of experiment, there is also a catalyst, which is the manganese sulfate. So catalyst is a substance that was added in a reaction to increase the rate of reaction, with, and it is not used up at the end of the reaction. So when catalyst is present in a chemical reaction, the rate of reaction increases. This is because catalyst speeds up the chemical reaction by lowering the activation energy that leads to the increase of effective collision between particles in the chemical reaction, thus increasing the rate of reaction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zimi Jaman. So my part I will talk about the question. For question 1, equation for the reaction that occur in part A and B is part A NO2S2O3 plus 2HCl equal to S plus SO2 plus 2NaCl. And part B 2KMnO4 plus 3H2SO4 plus 5H2C2O4 equal to 10CO2 plus K2SO4 plus 2MnSO4 plus 8H2O. So the function of the catalyst used in part B, function of catalyst 10% MnSO4. Solution in part B is to increasing the frequency of collision between reactant as altering of the orientation of reactant. Next, it functions to reducing intermolecular bonding with the reactant molecule and donating electronegativity of reactant. Conclusion from the graph, temperature is directly proportional with the rate reaction and catalyst is directly proportional with the reaction of rate. Next, for the conclusion, all the objective in the experiment was achieved. The effect of concentration, temperature and catalyst on the rate of reaction was studied from this experiment. The concentration is directly proportional with the rate of reaction. The greater molarity solution, the greater rate of reaction process. Temperature also directly proportional with reaction rate of experiment. If temperature increase, then the time it takes for solution become colorless will decrease and reaction will increase. Catalyst also can affect the reaction rate with lower interaction energy, so that reaction rate will be increased. For this experiment recommendation, to get accurate result, make sure the X marks is drawn clearly and large enough on the paper using pen link. Second, to get better result, ensure all solution measurement are done properly using the apparatus with the eye should be perpendicular to the measuring needle to avoid error. Third, make sure time taken to process occur are taken properly by focusing on the reaction carefully and acting quickly to press the stopwatch. So the last one, make sure boiling water are in the accurate temperature before taking the data, so we can get the accurate result based on that temperature water. So I think that's all from me as well as from our group. Thank you.